and then we'll start. All right, number 5 on the review. So g of t equals 2t natural log of t plus natural log 2 minus 2t plus e. Okay, a lot of stuff going on there. Let's see if we can get the camera to focus and stay focused. All right, I think I would first distribute the 2t. I guess you wouldn't have to. You could do a product rule with this as f and then all of that as g. But I think I would just distribute. I think that's going to be a little bit easier. I'm still going to have to do product rule, but that's okay. So product rule on this first piece. So f prime is 2. G prime is 1 over t, so that's pretty easy product rule to handle. So G prime, oh, careful, whenever the main function is named f or g, and then we have product rule with f and g, it's fine, just to be careful that you know who's what here. So
I thought it was a division sign in between.
I think it's a plus sign.
Oh, okay.
I think it's a plus sign.
Maybe that's why I got such a difference.
Because otherwise it would be, yeah, I think it's supposed to be a plus sign.
Okay.
So that should make it a little bit easier. I'm going to go ahead and finish the problem for later. So fg prime would be 2t times 1 over t. Obviously that'll simplify. Plus 2 natural log t the other way. Plus, and this next one, this messes people up, this one sometimes, because natural log of 2 is just a number. It's just a coefficient. It's just like the 2. So a different way to write that would be 2 natural log 2 times t. And the derivative of t is 1, and then you just have that constant left over. So 2 natural log 2. Oops, I wrote something down wrong from that previous one. So there's the product rule. The derivative of that, the t goes away, and so you're left with just 2 ln 2 minus 2. And then the derivative of e is 0, because e is just a constant. So that's thrown in there just to try to trick you, throw you off. That would be a perfectly acceptable safe stop free response answer. My guess is we would clean that up a little bit. And sure enough, the 2 minus 2 goes away. And these, you could leave it like that, but you could also combine, right? If you're adding with natural logs, you can multiply their arguments. So 2 natural log 2t. I did not grab the answer key, so I'm flying blind. I hope that's right. Other questions?
That was the only one I had, I'm pretty sure.
Okay.
Actually, let me find which worksheet it was. On page 352.
Okay.
Number 28. There's a graph.
352, number 28. Let me find it and we'll talk about it. Oh, yes, like you said, it's a graph. So it's probably a process of elimination is probably the best way to get there. Let me get my camera to show it. Let's see here. There we go. Get there eventually. All right, match the equation with the correct graph. Assume that A and C are positive real numbers. Excuse me. All right, so do probably just process of elimination to get there. C looks like regular exponential growth, so that looks like 25. D looks like exponential decay, so that's 26. And then 27 and 28, I'm looking at A and B. They both head toward 2 at the positive end, so that doesn't, I don't want to look when X gets really big, but when X gets really small, one of them goes to negative infinity and one of them goes to 0. So I'm kind of looking, it's not really a limit question, but that's kind of what I'm doing. As X gets really small, I need to look and see what happens with 27 and 28. So 27, C1 minus e to the negative ax. So C is just a number. 1 minus e to the negative, a is just a number, negative infinity, that would be a positive infinity. And so this thing would be headed off to 1 minus infinity. That would be headed toward negative infinity. This one was 27, sorry. And so the graph that heads toward negative infinity is graph A. And then if I wanted to do 28, limit as X goes to negative infinity of this graph. So that would be C over 1 plus e to the, let's see, negative infinity times the negative a would be infinity. 1 divided by, or C divided by infinity, that would head to 0. And that matches graph B. So C and D I got because I know what exponential growth and decay look like. A and B I looked at, for 27 and 28, I looked at what happened as X went toward negative infinity to see the difference between the two graphs.
Okay, thank you.
You're welcome. I'd also say there's not anything quite like that on the test. I mean, maybe there's limit stuff, but not exactly like that.
Could you go over number 5 on the review?
Yes. First thing I'd say about number 5 on the review is that, there it is right there, is that that's a plus sign in there, not a division sign. Does that answer your question? Or was that the issue?
Oh wait, I'll just take a picture of that. I can go over that.
Okay.
Can you also do 11 then?
Yeah, there's the rest of it. So if you need to, I'm recording and I'll post later, by the way. So number 11. Yes, good question. Let's look at number 11 off the review. K of x equals natural log e to the 5x plus natural log of 8. Well, we like algebra first if we can do it. So even before I take a derivative, I hopefully recognize that, wait a minute, I can do this. And the natural log of e is 1. And so a much easier way to write this is 5x plus natural log 8. That's still not calculus. That's still just algebra. But it's going to make my calculus a lot easier now. So k prime or dk dx, I guess, Derivative of 5x would be 5. Natural log of 8, that seems a little bit weird, but natural log of 8 is just a number. So I don't know what number it is, but that's just a number. So the derivative of a constant goes to 0. So as weird as it looks, it goes to 0. Other questions from the review or anything else?
Can you do 14 on the review?
Yes. Good pick. That's an implicit problem because it's not defined for y. So we'll have to take derivative and just deal with dy dx when they show up. Again, I can't start this problem by saying dy dx equals because it didn't start with y equals. So I have to just go through and on each term take a derivative. So 3x squared plus 3y squared dy dx minus, I've got product rule happening here. So I'm going to hold the 9 out front and then do the product rule on xy. So first times derivative of the second plus second times derivative of the first. And then the derivative of 0 is 0. From this point, it's an algebra problem. There's several questions on the test where the first step is calculus, and then it's a lot of algebra after that. So make sure you show your work so I can give you partial credit or even most of the credit for getting the algebra part or the calculus part right. I need to get the dy dx's by themselves and everything else to the other side. Don't want to do too much at once. The 3x squared and the 9y can move over. So on the other side, that would be 9y minus 3x squared. Then I'll factor dy dx out from what's left. And that leaves 3y squared minus 9x. So then divide both sides to get dy dx by itself. And so there's my answer. Actually, I guess that's not quite the answer because it said find the slope at 2, 4 and at 4, 2. But I'll leave that for you to finish because now you're just plugging in 2, 4 and 4, 2.
Thank you.
I will if I need to, but I suspect that was the heart of the problem that we did there. What else from the review? That was a good one because that's implicit. That's not really this unit, but it's something that people sometimes struggle with, and I'm glad you asked that one.
Can you do 15, like any of them, really?
Yeah, those look kind of funny. We did a warm up kind of like some of that. Actually, I can write on the page for this one. So find f prime at 2 for each one. So for A, f prime. The other side is something squared, so I need to use the squared rule. So I'll bring the 2 down front. I'll leave what the inside is the same, g of x, but then chain rule multiply by the derivative of g. So all of those have to do with, I guess, chain and product rule. When you don't actually know the function, you're just using g and g prime. Make it that far. Now it's just time to plug in 2. 2 times g of 2 times g prime of 2, which I think they gave us both of those things. So 2 times 3 times negative 4. 2 times 3 times negative 4 would be negative 24. You want me to do B or C?
Could you do C?
Okay, we'll do C. B is, I think, close enough to C that if we do C, we'll be okay. X squared times, so I'm already thinking product rule here. So F prime would be 2x. G prime is going to be, okay, so G is natural log of something. So it's 1 over the something times the derivative of the something. And we don't really know what the something is. We just know that it's G. So 1 over G and G prime. But again, they gave us a little bit of information. So we'll be able to work with that when we get toward the end. All right, so F prime. Again, with F and F, multiple F's in there. I don't think people have a problem keeping it straight. Just be careful. F prime isn't 2x. That's just part of the product rule we were working on. So first one times the derivative of the second one. So that would be x squared times G prime over G. Plus the other way around, 2x natural log of G of x. And now it's just a matter of plugging in 2 everywhere and seeing if we've got enough information to answer this thing. So yeah, f prime of 2. So 2 squared, oops, 2. G prime of 2, G of 2. Oh, I guess if I'd been thinking ahead, I could probably fill these in on the fly, but oh well, better safe than sorry, I guess. G prime of 2 is negative 4. G of 2 is 3. G of 2 is 3. So negative 16/3 plus 4 ln 3, and we're not going to get any better than that, so we'll just leave it alone with that as an answer. That's a good one. Like, that's similar to a warm-up yesterday, and it's similar to one on the test where, you know, part of the function, part of the function is defined just as G or F, and you've got to just kind of deal with G and G prime as you do the product rule or the chain rule or both. What else do you guys got?
Number 10 on the derivatives of inverse function worksheet.
Okay.
I get halfway through, like 1 equals tan of x, and then taking a derivative of that after you find x. I just didn't know like where to go after you find the secant squared x.
That's right. That's when we change to
Yeah.
tangent of x at x equals 1. Is that right?
Yes.
Okay. Again, I completely think it's worth it to take the time to set up the little table. If you can do it without it, that's fine. But I think it's worth the time to put things in the right spot. So we're trying to find the derivative of the inverse, but we can't get straight there because we don't have, well, I guess the inverse is the inverse tangent, but that doesn't really do me any good because I don't know the derivative of the inverse tangent. So we're going to go the long way around. So I'll work the whole problem. I know you said you got this far. So tangent of x is equal to 1 at pi over 4. So that's my x value for the original function. F prime is, derivative of tangent is secant squared. You do need to know that for the test tomorrow. So F prime at pi over 4, secant squared of pi over 4. And is that where you got stuck?
Yeah, I put secant squared like 1 over sine x times 1 over sine x. And then I got the square root of 2 over 2 times that and still got 1/2. I don't know how.
Secant, you remember who secant partners with?
Or is it cosine?
It's cosine.
Oh.
So cosine of pi over 4, although I guess that shouldn't have mattered because cosine and sine of pi over 4 are the same thing. So, so let's see, cosine of pi over 4 is root 2 over 2. By the way, this is, if this is a free response question, you could stop there with that answer. I mean, it kind of looks ugly, but it's acceptable, especially since we're about to flip it over again and be okay. Because to get from the derivative of the original to the derivative of the inverse, we flip it over. So root 2 over 2 squared. That's kind of a weird answer to leave, but it's an acceptable answer to leave. 2 over 4 would be 1/2. So 1/2 would be the best answer. I shouldn't say best. 1/2 would be the multiple choice answer. This guy would be an okay free response answer.
All right, thank you.
You're welcome.
Referring back to 14 on the review, so if it just says find the slope, do you have to write the whole, is it asking us to write the line?
No, it's just asking for the slope.
Okay.
So the answer will just be whatever we get when we plug in 2, 4. That's a really good question because you got to, we could ask 10 different things. Find the derivative, find the slope, find the tangent line, and they'd all involve taking a derivative. It's just what do you do when you get there? Do you want me to keep going so we get a definite answer for at least one of these?
Either way, I got it. I was just making sure.
Okay. I'll do it at one of them, dy dx at 2, 4. So I just need to plug in 2 for x, 4 for y. So 4 for y, 2 for x, 4 for y, 2 for x. So just be careful as you plug things in. And actually, free response question, done. Like why risk messing that up? 36 minus 12 over 48 minus 18. Again, any of these spots along here are safe stops and are acceptable. So I'm just working this in case it's a multiple choice question to get to the final answer. And then both of those will divide by 6. So 4/5 would be the multiple choice answer. It's not the best answer, it's just a multiple choice answer. So that would be the slope at 2, 4 is 4/5. Other questions? Well, I'm going to pick a question then. So you know it, that's a good one to pay attention to. Number 7 off the review. Y equals natural log sine of x plus cosine of x. I hope you think that's not really a difficult one, but it does mirror one that's on the test. So dy dx or y prime, either way you like it, equals 1 over the argument times the derivative of the argument So derivative of sine is cosine. Derivative of cosine is minus sine. And I don't think there's anything more we can do with that. But the one that's on the test, so here's your little hint for joining in a Zoom tutoring session here. The one on the test is kind of like this, except there's more algebra. There's more simplifying, factoring out things to do after you reach this point. So I think everybody will reach that point, but it's a multiple choice question, and your answers don't look like that because there's algebra to do. So there's nothing more to do with this one, but if we had to rearrange things, then maybe we could have had factored out a trig function and then reduced what was left. So that's enough of a hint for that one. I think you'll recognize it now when you get to it tomorrow. You know that you got to know sine and cosine and tangent. Here's your other hint. Don't forget you also need to know secant. We don't test it often, but we throw it in once in a while. The derivative of secant of x is secant tangent. Again, that's in the list of things you're supposed to know, but it's not something we use often, so it's something that well, people forget because we don't use it very often. And that may or may not be related to the hint that I just gave you on the problem. Just giving away answers here. Other questions? So we did natural log. We didn't do an exponent question. And we did some implicit. We did a derivative of an inverse. So you've seen a lot. It's been a productive 30 minutes. Anything else?
Number one, you would start with quotient rule, right?
You could start with quotient rule.
Is there an easier way?
Kind of depends on the person, I think, because you could divide both of those by x. So you could rewrite that as x squared plus, I don't want to do 25 over x because I don't really want to take a derivative of that, but I could do it like that. So yes, you could do quotient rule, but it might be easier if you did it this way. So 2x minus 25x to the negative 2. The big difference would be, well, there's no difference at all, I mean, in terms of mathematically, but on a multiple choice test, when you get the multiple choice test tomorrow, there's one, it's not exactly like this one, but there's somewhere where you get something like this, and the answer choices, they've combined, they've added like terms, and so they've gotten a common denominator, and so your answer doesn't look like that, and the reason is they made a common denominator, so the multiple choice answer might look like that. And if you had done quotient rule, you might get to that a little bit easier. So the quotient rule is harder on the calculus, but it might be easier on the algebra. The way I did it was easier on the calculus, but we had to do a little algebra. So.
Okay, thank you.
You're welcome. And this is another one where right there is a perfectly good safe stop, but multiple choice is probably going to do some algebra tricks with it. All right. Well, thank you to you five for joining in. I don't know why your slacker friends aren't here, but I'll post the video so that they can enjoy it later anyway. Anything else? All right. Well, I hope you guys are enjoying your sort of off day, at least you guys that are normally here at school anyway. And I'll see some of you tomorrow. Well, I guess I'll see you either on Zoom or in person tomorrow, and good luck.
Thank you very much.
Yeah.
You're welcome, guys. I'll see you later.